Hello, good morning, afternoon, evening, wherever you might be. I'd like to welcome you to the exciting topic of HPCC Systems Platform Metrics. I'm Ken Rowland. I'm a consulting software engineer working on the platform team. I've been working on metrics for the platform for a while now. I originally started working on ECL and I moved to the platform team after about a year or so at the company. So let's dive in. So today I'd like to talk about these general topics related to metrics. First, I'd like to give you an overview and a little bit about the motivation for the platform metrics. And then I want to talk a little bit about the difference between metrics and logging. And then I'm going to talk about our solution, the Metrics Manager, some of its goals, how we centralize support in the manager in order to make things easier to do for components in the platform. I'll talk about some of the metric types we have implemented. Then I'll talk about how you can instrument a component, and I'll show you how simple that is using the platform metrics. Then I'll talk about something new we've added recently, which is the ability to do execution profiling automatically with your ESP services, if you have those and you'd like to do that. Lastly, I'll give you some examples of where metrics can be used, both from a standpoint of something that's kind of theoretical, where it would have been helpful, down to how we've defined some ways we may use and combine metrics in the platform moving forward. So, why do we need metrics? And most of you probably already know these things, but infrastructure as we know it has evolved a lot, from just little desktop applications to in-house data centers to cloud-based systems. And most of you might know that we're on a path to move our stuff to the cloud as well. So the question, what is going on, is getting harder and harder to answer. And you don't have the ability to walk up to the system like you used to. Even in the data center, if it's in your building, you could walk up and you could run top, or you could kind of see what's going on. In order to have a good understanding of the health of the application and what's going on, you need good monitoring. It's critical. Metrics are a foundation for an effective monitoring strategy. Now, I'm not talking about your simple CPU percentage or memory usage, bandwidth on the network, things like that. I'm talking about application-specific metrics, and that's where the platform metrics solution is designed to shine. It really helps what's going on internally. Are you getting a lot of requests? Are those requests bogging down because your cache is too small internally in your application? Those are the kinds of questions that platform metrics can help answer. Now, it's really important to understand that metrics do not replace logging. And I'm going to spend a little bit of time talking about metrics and logging. So overall, platform metrics is a complete part of a complete system reliability engineering solution along with logging. So when I started working on metrics in the platform, I got this all the time from people on my team to other people I spoke to. Yeah, but I already have logs. Well, I want to say that metrics do not replace logging. Logging still remains a critical part of your system for maintaining reliability. And it's not a substitute. You really need metrics separate. So I want to talk about some of the differences where logging and metrics differ. First, metrics are generally out of context. There's no information in a metric about what was necessarily going on. It's just a count of requests, a queue size at this particular moment in time, whereas logging is contextual. They're usually in logical points in your code when you've completed something or starting something. Some event may have happened, something went offline, something went online. So they're very contextual and they contain a lot of information and are important. Metrics are numeric. They're generally just counts, a number, a set of counts, whereas logging is text. They can be long. They can contain contextual information such as the process identifier that's running, a request ID, All kinds of different information can be in those values or in those strings. Metrics are easy to aggregate. They're just numbers usually. You can add them up, you can average them, you can find the max, you can find the min. Whereas in logging, you have to use some pretty advanced textual analysis processes in order to look at them. For example, you might need regular expressions to pull out the things you need. And, oh, by the way, if the same programmer entered the same log statement at different points, you're in good shape. But, well, somebody else may have put something different in a log statement elsewhere to change the format. So that analysis can become complicated. Metrics are pretty inexpensive to store. Over time, numbers don't take up a lot of space. However, over time, logging does take up a lot of space. Metrics, very efficient to process at scale. Adding numbers happens very quickly. But logging, talked before about the analysis that you have to do to process them, it can be very costly. So metrics generally useful for monitoring, alerting, trends. Think of the number of requests. You can monitor how busy your application is. Alerting, the number of requests received is beyond some threshold. Trends, look how they happen. Look how your request demand happens during the day, so you might want to scale up. Logging, very useful for functional domain analysis and deep dive problem research. Don't replace them with metrics. I'll sum this up with this statement. Comparison, think of logging as lists of discrete events packaged and optimized for deep drill down analysis, while metrics are packaged to facilitate a continuous view of your environment, how it's changing over time, and are optimized for aggregation and numerical analysis. That kind of sums up the difference. I think this difference is very important to anybody who is considering system reliability engineering for their application. So I'd like to take a little poll. I'd like to know how you feel. I'd like to know if you feel you have a good understanding of the differences between metrics and logging and their respective domains. You can take into account the things I just said. So take a few seconds here, find your mouse. Please answer the question. I'll wait just a moment before I move on. Okay, thank you. Oh, I did forget to say, if you have any questions about metrics, please drop them in the Q&A, not the chat, the Q&A. We'll be monitoring that and providing answers during the presentation. So let's talk about metrics in some detail. You must have effective metrics in order to have a good monitoring system, an effective monitoring system. You want it to be useful. You want it to be something that is providing you a picture of what's going on. So good metrics are understandable. The count of requests, the queue size, the number of errors you've experienced, those are all pretty easy to understand. The number of times you executed this particular algorithm versus that particular algorithm, or why you took this path down code, those are not really understandable from the outside looking in. Metrics must be comparative. The number of requests, I keep coming back to that particular one, but it's a very good example. You can compare the number of requests you've received from this period of time to that period of time. You can compare the queue size. Those are easy to compare. They're generally simple values. It's just a number, just a number. So, and they have to be useful. Now, usefulness means that it has to be actionable in order to change behavior. If you have something which is telling you how many times you took this particular path down your code, you're not going to take any action on that. But if you have something that is counting your requests and you see the demand going way up, you could change your behavior. You could scale up. You could, well, basically you probably just scale up. So let's talk about some of the goals in the metrics manager. Now, previously, if you may have attended my presentation a couple of years ago, it was called the metrics framework. The metrics framework implements the metrics manager, and I might use those terms interchangeably, but generally it's the metrics manager that is part of the platform now. The goal was to centralize functionality and support in the manager to minimize the amount of requirements on a component in order to implement platform metrics. Instrumented components, and this is one of the biggest parts of it, are independent of the metric collection system in use. And I'll talk about that particular part of it in more detail later. But for example, I don't know if anybody's looked at how you might instrument using Prometheus or Elasticsearch, Datadog. All of these are different. Well, the metrics manager isolates the component from the peculiarities, the particulars, or how any of these particular collection systems are used. And again, I'll talk about that a little more later. So all of these lead to this next bullet, which is to simplify component instrumentation. That is one of the primary goals of the metrics manager, put most of the support into the manager and make it easy for components. And I'll give an example later of the type of code that you would have to write in your component in order to use the manager. And since we are moving to the cloud, we have to support both cloud, Kubernetes, and classic VM-based deployments. And the manager does support those. Continuing about centralizing support in the manager, the framework itself defines the base metric types. It handles most of the requirements related to those. All you really need to do is create them and update them. The manager also maintains a collection of the registered metrics, and it ensures uniqueness using a set of naming standards just to ensure that you don't create the same metric twice, because otherwise you would know what you're tracking. The manager handles all serialization. Now there's really kind of two parts where that happens. First is in metric updates, and that's where you would record events, such as updating the request count, or maybe changing the value of the number of active requests. And then there's collection, where the collection process, which I'll talk about shortly, needs access to metrics in order to pull the values out and report them. So I've mentioned the collection process, I've mentioned the isolation, and this is all implemented in something called the metric sync. It handles the connection between the manager and the collection system. There is no direct link between components and the metric sync. So they're completely isolated from that process. So the manager also supports the data collection process, providing capabilities to syncs for that. So syncs, again, metric syncs are the connection between the manager and the collection system. They handle all of those particulars. They isolate the path, excuse me, they isolate the platform from the components and the collection system. Once again, components are unaware of the collection system in use. They are defined in the platform configuration. What I mean by that is you configure the platform for which sync or syncs it is using during initialization. The manager loads those syncs, they're separate libraries during initialization, and they have a very specific interface that is followed. The sync handles metric value collection, which is packaging metric values for the collection system and then reporting those values to the collection system. And one thing about the manager is it does support multiple syncs. We're not really using that feature right now, but for the future, you could actually report values to more than one location at a time. Metric collection. I think it's important to understand what happens during this process, even though components are really pretty much unaware that this is happening. It is the process of collecting, packaging, and reporting values to the collection system. Again, the sync handles that. There are basically two types of collection methods, polled and periodic. Now, I should note that metric collection should be happening on a regular basis, every minute, every 10 minutes, every 10 seconds, whatever the requirements of your particular cluster application have. But polled implies that the trigger comes from something external, whereas periodic is driven internally on whatever that period you've defined for your platform is. The metric sync is in control of this process. For a polled metric sync, it would listen on a port, for example. It might listen on a pipe or have some other external event that it understands, usually driven by the collection system that would begin the process of collecting. For periodic, you would start a timer, and there's some support in some base classes for those types of metric syncs. So that timer would start, and every time it fires, you would execute the collection process. Managers provide support. They query the manager for the metrics to report. Each metric itself provides methods to query the values so that the sync can get those values and begin packaging up. And there's some other support methods in the manager for the collection process. Moving on, I'd like to talk about the metric types that are available inside the framework. Now, these are defined for use by components. First is a counter. Counter is a monotonically increasing 64-bit atomic unsigned integer. Okay, what does that mean? Well, atomic implies or should mean to some people that any updates, reads, writes, an update are all atomic operations. That's how those are serialized. These are used to count events, requests, cache hits, other types of things like that. Failures. So you would instrument your component with counters for the events or the things that you want to track. The second is a gauge. A gauge is also a 64-bit atomic, however, unsigned integer that increments and decrements. Well, I should say they're both unsigned, but the difference is that it's always greater than or equal to 0. If you try to decrement a gauge that's already at 0, it's not going to decrement and go to a -1 type value. These gauges are used to measure levels, queue size, cache size, things like that, things that are active generally. We don't do it, but gauges can be used to measure the temperature or water level and other types of implementations. But if you had something in your platform that was doing that, you could use a gauge for that. One of the features is you can actually create a gauge using 2 counters. You provide the input and output, essentially start and stop type counters, and internally the system, will subtract those when it needs to report and give you a gauge value. But it still will maintain the requirement that it's always greater than or equal to 0. One of the things we added is a custom metric. If you already have something in your component that is highly instrumented and all throughout, you can use that as a custom metric and tell the platform metrics manager to manage it. Well, I manage it in the sense that it becomes reportable. You still in your component would use it and count it and decrement, increment, whatever it is that, however you would track those events. But it has to be castable to a 64-bit unsigned integer. The component would manage all serialization related to collection. One of the newest metrics we have is a histogram, and I won't go into a lot of detail about it. You can look online, but basically it allows you to sample observations that vary in value. For example, request and response sizes, the number of megabytes or bytes that might be in those packets, execution times, and I'll talk about that a little bit later in the support we have for measuring execution profiling in ESP services. Histograms work by defining a set of buckets. These are ranges of observations that you expect to have. And as those observations are recorded, it picks the bucket where that observation falls and then increments a count. It also accumulates the count of all observations in each bucket and the sum of all observed values. A point to note that in each bucket, it's just a count of observations that fall into that bucket, but there's a sum of all. So you can still accumulate as needed, and the sync might accumulate these values differently than the way we record them, because the collection system itself requires histograms to be reported in a different way. It's important to note that you have to define these buckets, and there might be a little bit of tuning that goes on. You might look at some just regular sized buckets and see what happens, and then you might change those buckets because your request mix or whatever you're observing, that mix may vary or be different based on your platform. I'd like to talk now about how component instrumentation has been simplified using the metrics manager. If you've ever gone in, like I said before, and done an implementation of metrics for something like Prometheus or even OpenTelemetry, you can see that there's a fair amount of code that you have to implement inside the component in order to support those systems. What we've done is tried to simplify that. So first, you have to initialize the manager. The component will read the metrics configuration data, and that's passed in either through the environment XML or through values.yaml. The important thing is in the platform, that stuff comes in the same way, in an agnostic way. The component must create the manager and then pass that configuration data to the manager. It's important to note here that the component doesn't necessarily need to understand the metric configuration data, only to get it and pass it on when initializing the manager. And then basically you start collecting. You also have to instantiate metrics with the manager. And these are things like request counts that might cover cache hits and misses, queue length, things like that. And those are all the metrics types that we spoke about previously. Now, it is important to realize that you don't necessarily have to instantiate all of your metrics first before you start collecting. You can instantiate those after you start the collection process. And those will just get added to the manager, to the collection of metrics that it's managing. Next, you have to instrument the component source with updates for relevant events, such as when you receive a request, when there's an error, when an item gets queued and dequeued for a gauge type metric. So this is the only code that I'll show you. It's just to give you an idea of the type of code that will go into a component. So this is something that might be an ESP. The first section there is, well, you have to include the header file. You may decide you want to use the namespace and not prefix all of your metrics manager calls with the namespace. Personally, I like to do that so I know where it's going, but you can use it here this way if you want to. So the first line down there under the init shows you how you would get the tree for metrics from the property tree. Now the config there where you see the ESP config, that's usually passed into your component from the system. First thing you do is you create the manager. Then you would initialize it, sending it the metrics tree that you extracted earlier, and then you start collecting. The next section there shows you how you would create a metric itself. There are some convenience methods and functions in the manager to help you do this. This particular example is creating a counter metric, and the naming convention here would be esp.request.receive. There'll be more information about that available once we want people to start using it more. You provide a description and then the type of thing that you're measuring. In this particular case, the units are just a count. It is important to note that you have to maintain scope for the metrics you create. So p request count can't go out of scope, otherwise the metric itself would also go out of scope and no longer be measured or managed by the manager. Then throughout your code, you would put lines like this. You hear fast ink, it is just a fast way to increment it, and we recommend using that. If this was a gauge, you would have increments and decrements. If it was a histogram, you would have a different type of call to measure the observed value. Earlier, I spoke about something we've added into our ESP services called execution profiling. If you add an attribute to the service definition, the ECM file, you can enable it by default in the code which is generated by the interface definition language compiler. Basically, you would add the attribute profile underbar execution, and there are the parameters you would pass to it. First, you pass the units, that's a string, and the bucket size limits for each of the buckets, and it just builds the buckets for you and would instrument your code automatically. There are some options. You can turn it on and turn it off per method for the entire service. You could turn it on for the entire service and then turn it off for certain methods. All this will eventually be documented in the ESDL definition language. When included, this automatically generates code to create and update histogram metrics for each method, for each service method. So automatically creates the histogram and sets the bucket sizes. You don't have to worry about this. And it instruments each method with a new class that we've added called the histogram execution timer object. And that will take a picture snapshot of the current number of cycles and then count the cycles and then update the observed value when the section of code that is executing exits. You could actually use that elsewhere in your component if you wanted to as well. What I'd like to do now is give you some examples of how metrics could be used. And I have sort of three different things I want to talk about. The first one is to show how metrics would have been extremely useful for something we were doing internally. Now, metrics don't always have to be something which is only used by DevOps. You could add them for development version, collect them, and they're useful to determine, is this new feature effective? Was it in the right place? Things like that. The second is I want to show how metrics could be used to monitor SLAs. We all know how important SLAs are, but I bet we don't have the insight into where problems might be happening when an SLA goes out of spec. And then I'd like to show an advanced example of how metrics can be defined in order to provide a new metric to scale queue processors. First, recently we had an intern project to measure some improvements we were making internally in an HPCC component. All we had were log statements. So we had to use those log statements and the values generated in there in order to make the comparison. So what are some of the problems we have with that? Well, first, we had to make sure that we had the correct logging options enabled in order to make sure we got all the log statements out. And we had to also ensure that we knew the different log statements between the comparison versions. We had to, from the log entries, isolate the relevant log entries for the particular thing we wanted to measure. There was also extensive post-processing of these text-based log entries. Some of the entries weren't the same, so the statements or the regexes we used were different. And if you remember, I talked about that earlier, about how difficult it can be. So I already just covered it, but there's different log entries between versions of the source. Reruns were very, very time-consuming. Had to go through all of this each time you made a change to the feature to see how it affected the output. Had to recollect all log entries, had to isolate them, had to run the processing on them. And sometimes more log entries were added or different values were added to the log to collect more information. So as you can imagine, it was a very time-consuming process to do this. Well, How about if we had metrics that were just counting that? All you'd have to do is run it, check the values between a certain range of time, and see how it performed. It would have been much easier and much faster to do. The second example I want to talk about is SLA monitoring, service level agreements. These are not generally measured using a single metric. Well, from the standpoint of the customer, they say, well, it's just not going fast enough. They have a single metric. How long does that call take? Well, it's taking too long. Well, why is it taking too long? That's where metrics can be extremely useful. So an SLA monitoring metric or combination of metrics can take into account such things as processing time. How long is it taking to process these requests as they come in? Well, sometimes we have to go out to gateways, such as the address cleaner, or maybe even third-party external gateways. One of those is slowing down. So we can look at that as well. There might be some data lookup. There might also be some other service latencies involved. The thing to take away from here is that we can define multiple metrics and track each of these individually and monitor them and create alerts for when one of them starts going up, because it can signal that an SLA could go out of spec. So we would monitor also an aggregation of all these values, and that would give a picture, kind of what the customer might be seeing. So to know if they're going to be going out of spec as well. Lastly, my example for queuing is a little bit advanced. So the problem is to define a strategy that allows us to scale queue processors based on incoming jobs. A lot of things might go into that. So one of the solutions that we've talked about is to define some metrics that are based on a combination of simple metrics that we can implement inside components. So first, I want to define demands. Demand is the sum of waiting jobs and execution jobs. Basically, the total number of jobs that you have inside your application. Some executing, some waiting. And you may have different ways to measure that. The second area I want to define is capacity. Now, the capacity is the number of active jobs and the number of inactive processors. Basically, how much capacity do you have to execute jobs? And what we'd like to do is take these two values and come up with a metric that allows us to scale queue processors based on some items we define. So I want to define something called load. Load is demand divided by capacity times 100, so we can get to a percentage. Anytime that percentage is less than 100, we have capacity to start jobs. Anytime it's 100%, and the likelihood of being exactly 100%, as we know, is probably 0. But anytime greater than 100% is we're overcommitted. There are jobs waiting to be executed. So our strategy is to scale this capacity, the capacity to execute jobs based on target load and expected job duration. And what I have down here is some examples of values you might define based on your expected job mix. These are not necessarily values that you would always use. These are just examples of what you could do. So the first one, let's say all of our jobs are short. So we want a target load of 80%. And what that does is gives us the ability to have extra capacity to handle jobs as they arrive, so that we have good throughput and good reactivity. The second, let's say the jobs have a mix between 1 and 10 minutes. Well, we might want a target load of 90%. So that kind of balances some extra capacity to start some jobs, but keeps more of the queue processors active, so that we're not sitting there with extra capacity all the time. So if we have a long mix, maybe we just want to keep that mostly active, mostly committed at 95%. So it favors keeping the processor active with a little bit of capacity, maybe to start a job as it comes in, but the whole goal there would be we're always going to scale up when we have a mix of jobs coming in that exceed our capacity. So once again, These are just kind of example type things and ways you could use this load, which is a combination of demand versus capacity, and how you can take some scalar type metrics and build up this type of system. So what's next for metrics? We need to define a way to handle short-lived tasks. Sometimes tasks don't live that long, and we still want to be able to collect some metrics for them. We want to, inside of our ESP execution profiling, actually eliminate some of the standard support methods, such as ping, from actually being profiled. There's no need really to collect some of those things. We might support sending different metrics to different collection systems. Maybe you want to collect stuff to monitor SLAs in one system and monitor the application more directly in another. We want to support dynamic metrics. Let's say you have a metric, but there's a mix of things for what it's actually doing. So you might want to append to it some name for maybe a query name or something else. So we'd like to be able to support dynamic metrics when that mix maybe is not known ahead of time. We'll want to also investigate support for OpenTelemetry and Datadog in the platform. Again, just because we may not be using those, other people might be using them outside third-party vendors. That completes my presentation. Please feel free to continue asking questions in the Q&A, or you can contact me directly if you have any specific questions you'd like to ask. So thank you for attending. I know this is a very exciting topic, and thank you for sitting through it with me. Have a good day, evening, morning, wherever you might be.